Well, this is Unit 8, Section 8.1, Algebra Functions and Composition. Some things to remember, there's certain things called sum, difference, product, and quotient of functions. Means given two functions, f and g, the functions f plus g, f minus g, f times g, and f divided by g are defined as. So I'm showing you that f plus g of x on the outside is the same thing as you writing it as f of x plus g of x. If you're given f minus g with x on the outside, it's equal to f of x minus g of x. F of x times g with x on the outside is f of x times the g of x. F divided by g with x is f of x over g of x, where g of x cannot be 0. Remember the rules. 0 in the denominator is undefined, so make sure that whatever your g of x equation is not equivalent to 0. So we're going to try example 1. And so in example 1, we're given that g of x is equivalent to 4x, h of x represents x squared minus 3x, and k of x is x minus 2. So if we look at A, it says g plus h with x on the outside. Remember, g plus h on the outside is the same thing as saying g of x plus h of x. So we're going to replace the g of x. G of x happens to be 4x. And I'm going to put h of x in parentheses. And the reason I did that is in case this happened to be a minus sign, which means we have to distribute the negative to change the sign. So now we see 4x plus x squared minus 3x, and then just combine your like terms. So we have x squared is the highest power, x squared came first. 4x minus 3x makes it x, and we are finished. Now if we look at B, B says h minus g of x. So again, we repeat the same situation. It's now h of x minus g of x. H of x was x squared minus 3x, minus sign, and then the g of x is now 4x in the bubble. We are changing the signs by distributive property. So we have x squared minus 3x minus a 4x, and then consolidate. So x squared, negative 3x, and negative 3x is negative 7x, and you're finished. Now we proceed to start set C. Set C says g times k of x. So that's the same thing as saying g of x times k of x. So g of x happens to be 4x. And in parentheses, I'm going to stick my k of x, which is x minus 2. You're going to apply the distributive property to become 4x squared minus 8x, and you've completed your problem. When you proceed to D, it says k over h of x. That's the same thing as saying k of x divided by h of x. So we're going to look at our k of x. K of x is x minus 2. Divide bar, h of x. H of x is x squared minus 3x. So in parentheses, x squared minus 3x. Close it, and you are complete. Composition of functions. So the composition of f and g, denoted as FOG, which is we know as fog, is defined by the rule. F of g of x is f of g of x, provided that g of x is in the domain of f, which that means is that all the values of g of x, all the x values, are part of the domain of the f equation. The composition of g and f, denoted as GOF, is defined by the rule. G of f of x is g of f of x, provided that the f of x is in the domain of g, so it's vice versa. So what does this all entail? So if we look at example 2, it says we're given f of x equals x minus 5, g of x equals x squared, and n of x is the square root of x plus 2. So on A, they want us to find f of g of x. So remember, rewrite this the way it's supposed to be. So that means it's f of g of x. So what I'm going to do, I'm going to take my f equation, and I plug in the g of x equation into it. So it's saying f of x squared. I replaced by substitution g of x. G of x is x squared. That's the way it comes here. Now I'm going to take my f equation, but it says f of this. So we're going to write our f equation, which is x minus 5. Remember, we're doing f of x. Now f of x, now we're doing f of x squared. So in place of x here, we are sticking x squared in its place. So we finish with x squared minus 5 as an answer. When we look at b, it says g of f of x. So that's saying that they want g of f of x. So again, I'm going to write my g, and in the parentheses, in substitution of f of x was x minus 5. You're going to write your g of x equation, which was x squared. And in place of the x, we're replacing with x minus 5. So x minus 5 squared. This happens to be your expansion of your your perfect square trinomials, which means it's the same thing as saying x minus 5 times another x minus 5. When you expand it, we get x squared, because it's x to the power of 2. Then the middle piece is negative, because there's a minus sign. It's 2 times a times b. So 2 times x is 2x times 5 is negative 10x. Plus sign. It's the b value squared. Well, 5 squared is 25. Remember the rules from perfect square trinomials. If you see a minus b squared, the formula pattern is a squared minus 2ab plus b squared. And subsequently, if we saw a plus b squared, that is a squared plus 2ab plus b squared. These are your rules from perfect square trinomials. Part C says n of f of x. So we have n of f of x. Our n equation, our f of x equation is x minus 5. We're going to take our n equation. N of x is the radical, x plus 2. And we're now going to substitute in for x. So we become square root x minus 5 plus a 2. And finalize it to x minus 3. Continuing with 8.1, example 3, says given the functions defined by f of x equal to x minus 7 and h of x equals 2x cubed, find the function values if possible. So on A, they want us to do f of h of 3. F of h of 3, which means we can see this as f of x times h of x. The way I would do it first is actually write your f of x equation, which happens to be x minus 7, times your h of x equation, which is 2x cubed. Use the distributive property. I'm going in reverse now from the right to the left. So 2x cubed times x, that makes it 2x to the 4th minus 2 times 7, that's 14x to the 3rd. Once you're coming at this point, notice that there's a 3 here. That's what you're replacing x with. This is your x value being substituted in. So we're going to put 2 parentheses 3 to the 4th power minus 14 3 to the 3rd power. So 2 still slides down. Remember, you got to do 3 to the 4th power first. Rule of PEMDAS and GEMDAS. Grammar, excuse my dear Aunt Sally, or please excuse my dear Aunt Sally, whichever way you want to remember it. Exponents are first. 3 to the 4th power is 81. 3 to the 3rd power is 27. Then you're going to do multiplication here. So 2 times 81, that is 162. 14 times 27, using calculator, just because I'm very tired right now. 14 times 27 gives us 378. Looking right here, you see 162, which is, you have $162, but you spent $378 which we didn't have enough. So our answer is going to end up being negative. So when you do the math and subtract, you end up with negative 216. Okay, on B it says h divided by f with a 7. So think of it as h of 7 over f of 7. Could I have done this with example A? Yes, we could have just made it f of 3, h of 3, plugged in through 3 for both of them, individually done the math and ended up with the same answer. So it says h of 7, f of 7. So if we look at our h equation, h says 2x to the third, so we're writing 2, 7 to the third, because that's what h is representing. It says f of 7, 7, f of x is x minus 7, so I'm going to write 7 minus 7. When you do the math on the denominator, that's 343, I get 0. 0 in the bottom, remember the rules, that is undefined. You stop, you don't finish this problem. The minute 0 happened, it becomes undefined, unless you take the limit of a function, and we're not doing that right now. Okay, says h of f of 2. So remember, this is h of f of x, which is the same thing as saying h of 2. So when we look at our problem, we need to go to our f of x equation, because that's what happens to be the problem. So we have h, and then it's going to be x minus 7, and we're plugging in 2 into this, so we become h of negative 5. And then now we're plugging the negative 5 into our h of x equation. So 2 times negative 5 cubed. Remember the rules. Exponents have to come first. So negative 5 repeated 3 times, still negative, so it's negative 125. And then finalize your math. So 2 times negative 125 makes it negative 250. Now comes some of my favorite pieces. What if happens if they ask you to interpret a graph? The graph actually gives you your answers. You just need to look. So example 4 says the functions of f and g are pictured. Find the function's values if possible. So on A, they want us to find g of 2. So notice your equations. You have your coordinate plane, your x and y axis. The red graph line is your g of x equation. The blue line happens to be your f of x equation. Since A is representing g of 2, remember the 2 represents, that is your x. This is what the x is. They want to know if x is equal to 2, where is your y component? So we go to the red line, we go to x equal, here's 1, 2, x equal to 2. My y component is at negative 1, so I am an answer of negative 1. On B, it says f minus g of negative 3. So what they're asking you to do is f of negative 3 minus g of negative 3. So we're going to look at our f equation first, our f line. We're going to go to x equal to negative 3. Here's negative 1, negative 2, f negative 3, and we go down. The graph line is at y equal to negative 2. So I'm going to replace it by saying negative 2. There's a minus sign because I'm subtracting the g. I'm going to my g line. I'm going to negative 3. Negative 1, negative 2, negative 3. And I go up. I'm at y equal to positive 3. So I'm going to put 3 in parentheses. When you look here, it's negative 2 minus another 3, making it negative 5 as an answer. When you look at C, it says g divided by f of 5. So we're looking at our g of 5 divided by f of 5. So I'm looking at my g equation. I'm going to 5. So 1, 2, 3, 4, 5 at positive 1. F of 5, here's the red line. 1, 2, 1, 2, 3, 4, 5. It's at 0. What happens to this? Remember the rules. 0 in the denominator makes it undefined. And then the last one says f of g. So we're looking at f of g of -2. So first thing we gotta do is find g of -2. So g of -2 is first. We're going to -2 on the g line. -1, -2. 1, 2, 3. So I'm at 3. Now I want f of 3. That's the one we're looking for to finalize. So I go to f, which is the blue line. 1, 2, 3. I'm at 1. So my answer is 1.